What happened there? Oh my goodness. Good morning, good afternoon, good evening, whatever time it might be where you are out there. Welcome back to the live stream. My name is Jeff Fritz, and this is C Sharp with CSharpFritz. We're here live on the Visual Studio channel. It's all nice and sunny outside. It's always sunny in Philadelphia, and we're getting ready to talk about C Sharp, some programming techniques with C Sharp, and today we're going to get into a little bit of the design questions that we've had hanging out there. We've learned a bit about how to use the programming language, but what's a good way to put these things together that we've learned so that we can create better classes, better object models, better interactions so that we can create effective applications that are maintainable, performant maybe, and allow us to make changes without risking breaking things. So that's what's on the agenda today. Let me say hello to the chat room here. Good morning, chat room. How are you today? SourceGood is here. Looking forward to the stream. Loves Solid. Thank you so much. Our friend Layla Codesit is here. So good to see you. SourceGood and Layla Codesit are both MVPs visiting us, and they're live coders. Thank you so much for tuning in. Cushy Mushy, good to see you. Hootenheimer, good morning to you in Northeast Wisconsin. Got your first batch of snow. Oh my goodness. And it's only October and you already got snow in Wisconsin. That sounds like Colorado weather up there. Sending warm thoughts to us. Hootenheimer wasn't ready. It's only October. Well, yeah. Shy Sharp, good afternoon to you. Twillian in Brazil. Hello. Eckerd, yes, we are going to get solid. Oh my goodness. And is that Antique Raman in Sweden. Hello to you. Salvador Sarpi in Chile. Good to see you. Thank you for tuning in. Where else do we have some folks tuning in from? The Bomba Tenda from the Gambia. The Gambia? Not sure what that is. Ponce de Leon in Peru. Good to see you. Hello. Thank you for tuning in. Really appreciate. Where else do we have folks tuning in from? Let me make a change or two here. There's a thing. There we go. It's great to always see all the folks that tune in and join us from wherever you might be. And that's kind of the power that we have here on Twitch. The power for anybody, anywhere, to be able to dial in, to listen, have a discussion, and hopefully we learn from each other together. And we're going to have a good time. Maybe we'll tell some jokes. Maybe we'll learn something. We'll stumble into some interesting code and figure some things out together, right? Is that Dana Sarg in Romania? Good to see you. Thank you for joining us. So let me get some music playing in the background. We'll check out the GitHub repository. I'll make sure that you have a link to the YouTube playlist where all the rest of the videos in this series are available. And of course, if you're watching the recording, those links, you're going to be able to find them just below me here in the description. Links to the interactive notebooks that we're going to be using, links to the GitHub repository if you want to go in and ask some questions, send a pull request with some suggestions. You can do that. It's all available to you just below in the description. And if you're here watching live, we're going to have those links appear in chat in just a second. We play stream beats from our friend Harris Heller. This is free, royalty-free music that you can listen to on your YouTube channel, on your Twitch stream, that anybody anywhere can play without fear of any kind of copyright claims against you. So this is being played from Spotify, and this is the Synthwave playlist. And we'll get this playing in the background for a little bit of groovy music to kind of fill the gap when we're not talking. So, hello to you, Master Cram in Quebec. Good to see you. Thank you for tuning in. And there's a message popping up also in the chat from Stream Elements to make sure that folks know this is a beginner-friendly talk show format where we're not directly teaching the whole time, but we're going to be answering questions and interacting with chat. And if you have questions on the recording, submit those comments below and we'll be happy to come through and answer them later. Making sure that audio level is all right. I think that'll work. So, let's head over to the GitHub repository and I'll drop that link in chat for you so you can see where you can get involved here. We'll head over. There we go. And I will give you that GitHub link. There it is. To access the samples, this is github.com/CSharpFritz/C# with CSharpFritz. The link's there in chat. And like I said, the link is just down below here on the YouTube recording. Hello to you, Aswani Dut 93 in India. Good to see you. So, we've covered 8 topics already, and they're all available to you here inside the GitHub repository. You can go into the notebooks folder, and you'll see all of the notebooks that we've gone through to this point. And while that's nice, these are Jupyter notebooks that you can click through and look at. You can follow along if you're watching at home or wherever you might be. You can follow along in your favorite browser by clicking the Launch Binder button here, and it will launch that notebook from the Binder service, and you'll be able to tinker with the code along the way, be able to read the documentation, and any of the links that we put into the documentation, or any links that we research along the way here that we want to make sure we cover, we'll add those to the documentation so that you can jump out from there and learn more about the topic along the way. So, I have this downloaded and running locally on my machine using Jupyter Lab. If you want to clone this repository, there's a dev container here so that you can launch this using Visual Studio Code without having to install any other tools. It will run completely using containers on your machine, on your workstation. I'm seeing that that message is coming up just a little bit too quick for my liking here. I'm going to open up that beginner's message a little bit so it takes about 20 minutes to come back next time. So we're going to talk about design principles. We're going to talk about the solid design principles that are out there for folks to use when they structure and decide to build their applications and put together pieces of functionality using C#. So this is very much focused on using the C# language, and we're going to ensure that all of the samples are runnable, and we might tune them along the way, make some changes, and ensure that there's some interesting things that we can do with them so that maybe you want to use them later. So I'm going to jump over to Jupyter Lab, and this is a Jupyter notebook. So that's a notebook that runs with Python that has C# and .NET sitting behind the scenes that allows you to run all of that C# code live in the browser. So we can make changes, we can throw errors, and it doesn't break things. It all runs immediately in the browser and outputs immediately any kind of response codes that we need to take a look at. Thank you, Layla. I think this is very cool. So we're using this to learn more about C#, and we're almost up against our November series where we're going to break out of the browser and we're going to start getting into building real applications. And it looks like we're going to be doing Blazor first, and we're also going to have a C#9 update stream coming up in November. Belazial. Let me bring up that comment. That's a pretty good comment for us to touch on here. There it is. Just discovered yesterday that Solid even exists. Don't know too much about it. Well, let's get into this. Let's talk about this. So, Solid is a series of design principles, design patterns that were initially proposed by Robert C. Martin in his 2000 paper, Design Principles and Design Patterns. Developers, naming things are hard, but if you're going to write a paper about design principles, naming it Design Principles is a pretty good start. Later, these 5 principles, the acronym SOLID, was coined by Michael Feathers, and there's links to both Robert Martin's paper and to a Wikipedia article that talks about Michael Feathers and the SOLID coining. So, these are principles. Now, I want to make sure that folks understand there are some people who they're quite dogmatic in their approach to these. They feel that you must abide by these 5 principles. like all rules in engineering, and honestly, when we think about software walks that fine line between engineering and art. There are times to adhere strictly to the rules. There are times to bend the rules. And there's times to break the rules. For new developers, these are some good suggestions. These are some good things that you're going to want to investigate and learn more about, so that you know when it's appropriate to bend and break those rules. You'll find senior developers, architects, will regularly bend and break those rules. I recommend you adhere always to the number one feature requirement of software development: ship usable software. If you don't adhere to these principles and you ship software that works, that is phenomenal. You have folks that are using your software, you have customers, you have folks participating in your applications. That is feature number one. If you use these principles and it makes it easier for you to maintain and grow your application, to grow your system, that's even better. But it's not a requirement to have successful software. So, that's right, our friend Dev Chatter, he's another live coder that you'll find here on Twitch, produced a whole series of videos covering each of the solid principles, and we're going to go through them quickly today. And I say quickly because we're going to spend 2 hours and cover the 5 principles, and also talk about dependency injection at the end. Layla, you're right. You're very right. Let's bring up Layla's comment here so that folks can see. There are 2 camps, dogmatic and pragmatic. Both have their place. Some folks prefer a pragmatic approach. Some folks prefer a dogmatic approach. Each one of those can lead to success. It's up to you to figure out, and your project team to figure out which way will work best for you. So, we're going to discuss, and we're going to get in here, and there might be better ways to do things along the way. We want to make sure that we are open and encouraging to beginners who are following along with the session. So everybody's comments are welcome, but we don't want to get too advanced. We don't want to add too many features into the mix here, but discussions about the pattern are certainly welcome. So, House Bisuk, I don't want to get into folks doing advanced discussion around the topics and gatekeeping away and potentially intimidating beginner developers who might have questions about the patterns. So, oh my gosh, Priyank. Is that Priyank P? Says, 10 years experience and still following. Fantastic. Thank you for chiming in there. Appreciate that. So, the first of the acronyms, SOLID is an acronym, right? SOLID, stand for 5 different principles that we're going to explore through a series of demos. And we'll write some code along the way to test and tinker with each of these demos. Maybe take them in directions that weren't initially considered. Lithix has 18 years of experience of being a beginner developer. If you do the same beginner tasks again and again and again, have you really become an intermediate or advanced developer? Yeah. So, so let's talk about the single responsibility principle, the S in SOLID. A class should only have a single responsibility. That is, only changes to one part of the software specification should be able to affect the specification of that class. Now, that's kind of interesting there, and we'll simplify this. A class should have only one reason to be changed or rewritten. Conceptually, this means that you should have many smaller class objects that you can use to reference each other to perform a task, right? Gosh, smart guy who wrote that there. That would be me. So, I've seen folks that create this model, that the God class, right? The utility class that is able to do all things. It is omnipotent. It is the class that does everything. And that's kind of a problem. When you have a very large class that is capable of doing everything inside of your application, that class typically resides in one file, and now whenever you need to change some part of your application, everybody's changing that one file. So you start to run into collisions and issues, and right, you're going to have concerns as you're editing that same file to make changes for what might be very different parts of functionality. I'm going to use a logger example through our notebook here so that we can interact and use something that I think we're all going to be pretty familiar with. So let me take a look here at a couple of the comments in the chat room. Master Cram asks, let me queue up a couple of these comments here. There's a couple of really good questions and comments here. What is a beginner developer? Isn't design pattern already an advanced thing? So this is a little bit more advanced. However, discussing these patterns, implementing these patterns, I think is a little bit more intermediate. We've gotten out of the basic features of the C# language, and we're learning how to put those together beyond, in our previous sessions, we learned about interfaces and abstract classes. Well, what's a good way to use some of this object-oriented notation and structure that we learned how to create? So we're getting into that intermediate discussion here. There is a GitHub command, there you go, that you can use to access the notebooks and content that we're going to be following along here and tinker with. Go ahead and make changes, break it, and it'll report errors appropriately to you in the notebook without affecting anybody else. It'll be okay. Nick, the first one, chimes in. It's always good to rewatch stuff like this. I find that listening to the explanation of other developers helps you gain more insight. I completely agree with you, Nick. That's a really good point. Listening to other folks describe these, and even taking some time to describe it yourself. Write it down and what you think of some of these topics, and revisiting that description later after you've had a chance to implement. You've gone through a couple applications. It's going to help you learn and be more productive. Naloth asks, is this a book? That's not a bad idea. After we get through a couple more of these, it's not a bad idea to pull these together and make this a little bit more of an ebook type of content. So, not a bad point. Ancient Coder, that's very wise advice. Technically, everyone is a beginner at the most senior, as the most senior devs will be beginner in some technology or another. Not everybody's an expert in everything. So, we're always learning, and you can always learn something new. Great points. So let's talk about a logger object for this example. And if we were to create a logger object, right, maybe it has these 5 tasks. We're going to create log files on disks. We're going to name and rotate so that we write to different log files on different days, so that our application writes log content for today in the October 26th, 2020 file. And maybe tomorrow it writes in a October 27th file, etc., and so forth. We need to have methods so that you can write log messages into that file. Maybe we want to have some way to format the log messages, and so that it has a date stamp maybe at the beginning, or maybe there's some information that we want to carry along, some meta information we want to carry along about our log messages, and we want to format that appropriately. And of course, we need to close the log files so that it can be accessed and read by other systems. So we could start off with a massive, simply amazing logger class that is just called the logger. And I've just allocated some simple methods to do those things that we've described. Create new files, name a new log file, and we're going to name it after the current time in the UTC time zone, all the way down to the hour.log. And we'll have a method to log messages, and we'll have a method to format messages here. We'll close the log file appropriately, and when this class is disposed, as it's being cleaned up, we'll make sure we close the log file if it wasn't called already. So very simple, and I've purposely not included any file management information here. I don't write that. The implementation, what it actually does with the files, that's another discussion for another time, how you interact and write files and interact with files. But for the purposes of this design pattern and discussing this pattern, I think we're okay here with this level of interactions. So what I'd like to do is realistically look at this and think through. There's a lot of places, right? And our logger is very simple. Create a new logger, and we're going to say logger.format, error detected, and dispose. And right, we display that, and it puts out a nice format here that has the time, the message that I placed there, right? And it would write that to disk, theoretically, right? In this sample. And that's simple. That's basic, right? And it's a very complex class that does many different things here. But if we want to start changing, if we want to change the format of our messages, or if we receive a requirement that says, hey, Jeff, we want to centralize our logging. We want to push that to a RESTful service somewhere out on the internet where we'll be able to collect those, because maybe we've got distributed offices that folks are interacting with our application at. We want to be able to centralize all of our log messages. We're going to want to change that interaction. Well, now I've got to completely rewrite this entire class. The single responsibility principle says, well, let's break that out, because these are in fact different responsibilities of the log operation. Let's put those responsibilities into different classes, and we can put those classes then into different files, so that when we need to refactor, when we need to change that operation, so that we still provide the same facade, we still provide the same API to the rest of our application, but the way that we code and support that logger object is composed of these smaller objects. Each one of these smaller objects helps to enact that logger object and provides each one of those features. Then when we want to change just the naming, we have a place to go to do that. Excuse me. Is it Devin Goebel or is it Devin Obel? I think it's Devin Goebel. This is a good point here. Solid is made up of principles, and they are applicable to any technology. We're showing in C# today, you can apply these same object-oriented principles to JavaScript, TypeScript, Python, your choice. It doesn't matter what language you're programming with, but we're showing with C# today, and they can give you a leg up when moving from one technology to another. Spot on. Well stated. Thank you for sharing. So let's simplify. Let's start to separate out these responsibilities. So perhaps we have a file logger class to start that knows how to manage a file. It'll create files, it'll write messages to the file, and it knows how to close and clean up the file. And I just added a couple of display messages here that instead of actually interacting with the file system, it just outputs a little bit of a message for us. This way we can see that, oh, it's doing those things when we go to log a message here inside of the notebook. Continuing, perhaps we have a logger file name manager. And this is the one class that knows, here's how we're going to name our log files. So name new log file, and it goes and calculates that file name appropriately. We're going to display it just so you can see what that file name is, and return it to the calling method so we can interact with it. And we'll create a logger formatter class next that knows how to format that log message. So it'll receive my raw message that I'm going to write, and I'm going to prefix that message with a timestamp, a UTC-based timestamp, and the raw message that was sent. So I have this nice formatted message. I'll display it so that you can see it here in the notebook and return that message to whatever the calling method was. Continuing, now I'll have that composed object. Instead of having the omnipotent, the logger class, I'll have a logger manager class, and I make it disposable so that we're sure we clean up and we release all of the resources for our file interactions. So now this class becomes a lot simpler. Now this class is delegating appropriately to those child classes, these 3 child classes, the file logger, the logger file name manager, and the logger formatter, so that we create those when this logger manager is created, and we identify a file name appropriately when we start, create that new file when we go to interact with it, and when we log messages, we're going to reach into that file logger object and say, write this message out to disk. We'll format it appropriately and write that formatted message to disk. We'll dispose and clean up our files appropriately. So I still have the same syntax. Var logger equals new, in this case, logger manager, display logger format, error detected, logger dispose. I'm doing the same thing, except now I'm saying log message. And I don't have to do that format. It's doing it internally and for me, and logger dispose, and I end up with these messages being output. Here's the file name that's been decided upon, created log file, and it's got my file name appropriately. It's formatted my message, wrote message to disk, cleaned up, and closed log file appropriately. So we've got very simple series of objects that now drive the same features, and Ernesto is spot on here in the chat room. We are still coupled to the file infrastructure, but we are only at the single responsibility principle. This is our first refactoring. Spoiler alert, Ernesto is pointing us in a direction that will help us as we go through the rest of these principles. So we can change the format inside of our logger formatter class. We can change how we name our files using the logger file name manager class, and we can change the destination if we want it. If we don't want to write to a file logger, well, we can build another logger object and bring that into our logger manager class and use that instead. Okay, more about that last one in a bit. But logger file name changes, log record format changes. Let's talk about the log format changes. Log record format changes and logger format. That's going to take us into our next principle, the open-closed principle. And this is one that can get a little bit tricky, and this is one that I think folks will refactor ad nauseum so that they can make things as simple as possible. And this is where that balance between pragmatism and dogmatic approaches comes in. The open-close principle states software entities, classes, modules, functions, etc. should be open for extension but closed for modification. So this means that having a generic method that knows how to interact with and provide the business value is one thing, and be able to inject additional business rules will help to change that behavior, but provide support for new features. It means that you're only going to create new features by writing new code. You're not going to go into some existing code and change those business rules. And you'll see this with folks adding if-else else if statements, or a switch case statement, and they add more case statements into their logic. What if we can change that by introducing and passing in classes that do that, in this case, do that formatting for us and hand off that operation to additional operations? Not getting into diagramming today, Master Cram. Buna, we're trying to stay with simple class design interactions. So methods could certainly be done, but we're staying a little bit simple just so we and purposely adding additional code to show interactions that are easier and bigger for beginners to be able to see the differences between. So we have our file logger object, and that's nice. And we have our logger file name manager, but if we introduce an interface, iLogger formatter, that will format the log messages that we're going to provide, well, we can define an initial one here that we've already got called normal logger formatter, implements the iLogger formatter interface. We've already seen that interaction with interfaces and how you implement interfaces in our previous session. And you can find that recording over on the YouTube playlist, !YouTube, so you can see that. Or if you're watching on YouTube, click the playlist over on the side and you can go back to that. So now I have my log message method, but I can delegate, right? Remember, we can provide overloads to these methods. I can provide a second method that receives a logger formatter and will then use that to format the log message. And by default, so I have the same behavior, I'll default that to the normal logger formatter that puts the date and time at the beginning of the string followed by the message. Now, that's not bad. We're going to get the exact same thing written out, log message error detected, and it behaves the same way. So that's not bad. But if I want to enhance this, so that it knows how to log exceptions, I can provide an exception log formatter that will appropriately go and format our messages appropriately to handle exceptions. So I'll implement iLogger formatter again. This time, when I construct my formatter, I want to take in some exception object, stash a copy of it here in this private variable. And now, when I implement the format log message method, I'll include that date stamp, and I'll also report an exception of type, whatever that exception type was, and whatever the message of that exception was thrown, and whatever message we send into the log message method. So I've now expanded the capabilities of being able to log using my simple logger class by introducing an additional method, an additional class that implements this method, and we can go forward and use. So we're still using the same log message, right? Logger log message, and I'm introducing my formatter object here with information about that exception that we need to handle. Everything is on fire. So error detected, everything is on fire, so it created log file, and here's the new message that it wrote. Timestamp, exception of type exception with message, everything is on fire, logged. Error detected. So think about this. Inside of your applications, as you're building and working with expanding the facilities, adding new features, instead of maybe doing an if case, right? If else or switch case types of statements, being able to pass in, maybe in this case, a formatter, or maybe there's a different business logic for different scenarios that you want to be able to handle. being able to pass in and send that business logic in through a common or a shared interface is going to help you to be able to enhance that business object with some new business logic that has these facilities. That's right, Mr. Demon Wolf. You've spot on here. Everything is fine. Being on fire is normal. Well, if it's a barbecue, yes, you're doing just fine. Barbecue, it should be on fire. But if we're in a hospital, not the case. So, we've now enhanced our logger manager by introducing an iLogger formatter, so we can pass in different features through that interface. The next principle is the L in Solid, the Liskov substitution principle. This one, and it's named for, I forget who Liskov is, but objects in a program should be replaceable with instances of their subtypes without altering the correctness of that program. This means your object that's referencing a base class shouldn't have to know anything about the child class in order to interact with that base class. You should be able to swap those objects out, interacting with them inside of, in this case, my logger manager class, without having to actually change the code in my logger manager. So we don't have to rewrite the logger manager if we want to change it from logging to files to logging to that RESTful endpoint. Let's dig in a little bit further here. So if we want to sync instead of to a file, right? We call these syncs, right? Instead of syncing to a file, if we want to sync to somewhere on a web server, to a RESTful service, we can define an abstract class, a log sync, that knows how to write messages. It doesn't know how to do anything else, just knows how to write messages. And we can start to re-implement our file logger with a log sync, implementing that as an abstract class that knows how to create a new file. It's not part of that implementation. It knows how to write a message, and it knows how to dispose and clean up that file. And my logger manager down here now is going to specify that it has a log sync that is a new file logger. We could change that in the future, so it's a new RESTful logger that implements log sync, and consequently, down here, when we log our message, logger write message, it knows how to interact with that. Not bad. But we haven't fully implemented we haven't fully implemented the Liskov substitution principle here, and we still have our logger manager needing to understand about the file, about what the file name is and how to manage that file. And you see it here in the constructor. It still has to know what these things are. So we need to do a little bit more refactoring to push these around a little bit. And in fact, you see here, I've got a couple of errors that we need to correct. So I think we should take some time here and let's correct these errors to fully implement the the Liskov substitution principle. Look at that. Looks like Rick did some research here. I'm assuming this is correct. The Liskov is for Barbara Liskov, was one of the first women to be granted a doctorate in computer science in the United States, and is a Turing Award winner who developed the Liskov substitution principle. Nice. Thank you for looking that up, Rick. I'll have to add a note here about let's add a note. Add note about. Well done, thank you, Barbara Liskov. And I will make sure that is in the finished version of the notebook. Much appreciated, Rick. The substitution in the headline is missing a substitute. You're right. Look at that. Pair programming at its best. Substitution. There we go. Thank you so much. So we haven't fully implemented this properly, right? We still have that some of the references to the file object lurking here that we need to correct. So we want to implement the same interfaces. We want to implement and provide that same facade of a log sync. So these things here, where we name new log file, create new file, and write message, these two, they need to go away, and so does the file name manager, because we're tightly coupled to the log sync being a file operation. So instead of them occurring here in the logger manager, let's move them up into the file logger so they occur there. Nothing says they must occur in here. We'll move them over there so that all the interactions with files occur inside the file logger. So I'll make that change now. I'm going to copy these, and for the purposes of continuity, so that folks that are watching the recording understand, I'm going to comment them out so that they're not referenced here. I'll go up to the file logger, and I will paste these in, and we're going to want to make these as part of a constructor here. So I will create a public file logger constructor. There we go. And I'm not going to create a file name here. I've already got a file name field available to me, so I'll just reuse that and create new file when the file logger is created. Now, realistically, you don't want to create a file every time you interact with the file logger. This has been simplified for the purposes of a sample. You probably only want to create a new file when it's time to create a new file. You'd want some logic that determines when it's appropriate to create a new file. And if it's not appropriate to create a new file, point to the existing log file on disk and interact with that appropriately. So, just some things to be aware of as we interact with this. So, continuing here, we still have this one, file name manager. This one we need to get rid of as well. So I'll comment that out and go back up here to the file logger and paste that in. So it has the same facade. And you know what? I think log sync should implement iDisposable so that we're sure that every log sync is disposable. So we know that classes can implement interfaces, including abstract classes. So I'm just going to move this iDisposable implementation up here. That way we're assured that our logger here is still supporting the dispose method here. So we just moved a couple of those features that we had inside Logger Manager. The rest of our public API for the Logger Manager is the same. And if we try and run the code now, log sync does not implement dispose. So I still need to go up here. The abstract class needs to implement dispose. So I'm going to create a public virtual void dispose method, and I'll be able to swing down here, and inside of the file logger, I'll override that. And now, how do I look? Do I have some executing code? The name underscore logger does not exist in the current context. Where's that? Line 17. Let's go fix that one now. So, as you can see, we're getting a lot more code, and that's okay. Here we go. This is actually this object, so I can delete that. And now, there we go. Now I've completed my interactions, and it's now behaving the same way, and that log sync references the file logger and has the exact same API regardless of how we implement it. So if we implement it to be able to surface and return RESTful interactions, or maybe we want to log to a database or wherever, send to a log queue, you can still do those interactions and substitute that other log sync appropriately for interaction here. Okay? So, very interesting ways that you can consider implementing and substituting different objects and passing them around and changing the behavior of your application. So, Eagle Hansen with a comment here in the chat room, very good point. An important thing about the Liskov substitution principle is that in addition to the public surface of the type, so if I go back up here to the log sync, and it has those two methods, not only those methods should be the same, but their non-functional behavior should also be the same. So the same exceptions should be raised so that they're still handled by the consuming class the same way. They're still processed and passed on to other interactions appropriately. Good point there. Thank you so much, Eagle. Appreciate you chiming in with that. So how we doing here? I'm looking at some comments here in the chat room, and before I move on to the I in Solid, let me see here. This is from Buna. I like the idea of using a game manager loot manager in game programming, and how to use this experience in business applications, for example, a notification manager, an authentication manager, and so on. Exactly. Right, in game programming, you might have a game manager that manages the interaction of the entire game. You have a loot manager that manages the loot that you're finding in game. In a business object, you're going to have authentication manager that you're going to be able to compose and interact with inside of your application, right? And you're going to have database manager, you'll hear folks refer to as a repository and the repository pattern, but you'll have these different classes, these different implementations that are able to handle those various responsibilities. Very good point, Boona. Thank you for sharing. Thank you so much, Layla. Appreciate you tuning in. And thank you, Jason. Appreciate you chiming in there. Priyank asks, can we have before and after code for Liskov in the notebook for comparison? So I've just commented them out. So, right, the changes are here and there that have been commented out, and right, moving these objects in here. So I will put a note in the comments here. So file name was there. This field and the constructor were added to complete the LSP implementation. There you go. So you can see that appropriately in the notebook. I hope that helps, Priyank. Let me know. All right. Let's get into the I now. So I is the one that we'll find folks get carried away with, particularly in C# and .NET circles. You don't see this too much in other object-oriented programming languages. But when we talk about interfaces, .NET developers love to create interfaces. And this is the interface segregation principle. Many client-specific interfaces are better than one general-purpose interface. So the idea here is to create these many little utility interfaces that do one or two things very, very well. That way, you only bring in those classes, those objects. You only load those into memory. Just those things that are doing the tasks that you are seeking out and you want to interact with. Right? So you don't need to load massive, huge objects, right? Think about our big logger object that we had up here that knew how to interact and do all these interactions with the files. This potentially could be a very large object with all of these interactions laid out inside of it. But in the interface segregation, we're going to split these out so that we have separate interactions, separate capabilities for each one of these things that we might be doing. Now, it is possible to create too many interfaces. You're going to just have to feel out when that happens. If you quite literally have one class that implements one interface, and throughout your entire application, you just have class interface, class interface, class interface, and it's one-to-one throughout your entire application, you've probably implemented too many interfaces. If you have more interfaces than you have classes in your application, you've probably implemented too many interfaces. So, be forewarned. I can define a couple of interfaces here to make it a little bit clearer the various things that we need, the tasks that we need inside of our logger sample here. I could have an interface for our logger formatter, and we already defined that up higher. A file name manager, we could define that interface as well, so that it's clear that this object just knows how to do this thing. And we could then create a single object, perhaps, that knows how to handle all of those things for us, right? Because if we're interacting with files, and this is, right, maybe not default file formatter, maybe this is the what did I do? I clicked the wrong button. Get back in there. Where'd my browser go? Did I close my browser? I closed my browser. Are you kidding me? No, it's over here. That's where it went. Whew. Maybe I don't want to call this a default file format. Maybe I just want to call this file handler, because it knows how to do all the things for files. So, right, it knows how to be a logger formatter. It knows how to be a file name manager and format my log messages, make new log file names appropriately for us. And that's okay that we have those implemented here so that we can pass those in and interact with those for our logger object. And I could define many other little interfaces that do these very basic, simple things for us, because and Devin points this out quite nicely here. As a rule of thumb in object-oriented programming, composition, composing together from these various interfaces, bringing together so that they build a larger object that provides more business value. Composition is better than inheritance, where we're inheriting from a base class and we end up with a large inheritance hierarchy. Implementing interfaces, implementing many interfaces, is going to give you a lot more control over the growth of your application. All right. So there's more that I could do here, but I think that's a good start for us. Moving along. The next principle that we want to talk about is the dependency inversion principle. And this kind of makes sense. We've been talking about dependencies, right? That's what we're going to get into here in the last bit, is dependency injection. But the dependency inversion principle, now that we've defined some base classes and some interfaces, depend on those abstractions, not concretions. Don't depend on concrete implementations of things. This way it becomes easier to swap implementations of things. Think about it. Format log message as an interface here, I can swap that out with a new implementation. That is, maybe it's file handler v2 that has our new implementation of that, and I can pass in a new version that does the same thing. Depend on that iLogger formatter or that iFileName manager, and we can swap those appropriately. Pass in a new implementation when it's completed. Test it, interact with it, make sure that that new class does the thing that we want it to do, and interact with it appropriately. Sorry, we're not going to. Sorry, Deflux, we're not going to answer questions about Blazor during today's session. That we can come back to either on my Discord server, or we can handle those questions tomorrow during my stream over on my channel. So, if we have tight coupling where we reference and we create instances of other classes inside of our class, now we're going to end up with a problem where we're tightly coupled to that. We require changes to class B be reflected in class A. But if we go through an abstraction, through an interface, through an abstract class definition, now we end up with something that's a little bit more loosely coupled, because we're referring just to that abstraction, just to that interface. Change the implementation behind the interface. Go ahead and make whatever changes, whatever testing you want to do. The interaction from our class stays the same. So, here's our original logger. How could we re-implement this so it only depends on the interfaces and abstract classes that we defined previously? Let's write a little bit of code here. Let's take a little bit of what we wrote, bring it together, and re-implement this so that it only references those interfaces. Before I get in and we start that exercise, I see a comment and a question here. And this is a good question that I touched on briefly. At what point does dependency injection or dependency inversion, become over-engineered? So I touched briefly on this. If everything is one-to-one, if you have one concrete class and it's the only class that implements an interface, and you effectively have class interface, class interface, class interface throughout your application, throughout your code, you're a little over-engineered. If you have more interfaces and abstract classes than you do concrete classes, you're a little over-engineered. You want there to be a few classes that implement the same interface, that implement the same abstract class, so that you're able to do that swapping. If you don't need to swap those references, if you don't have that extension point that you're going to need to cross for maintenance reasons in the future, and we have the requirement that was defined here that we're going to be looking at, introducing interfaces and abstract classes doesn't create technical debt. You can still couple directly to the initial classes that you are working with, but now when you refactor to introduce those interfaces and abstract classes, you're now opening yourself up, right? Open-close principle. You're opening yourself up for modification so that those new features can be brought into your system and enhance it, which will then only mean good things going forward when feature 3 becomes introduced, feature 4, and you're able to reference those interfaces, change and interact with those appropriately. So, we'll get into, and Eagle, I get into that in the next sample. So let's take this original logger. I'm going to, I just copied down that original source code that we had. And let's introduce another block here. And I'm going to copy in what we had for this block that had the log sync, the file logger, logger file name manager, etc. So actually I could have, let's copy this. So there's cool hotkeys inside of Jupyter Notebooks. Yeah, see, new is glue. See that, the next topic, it's right there. I can press V and it'll paste the section just below. So here's log sync. File logger implements that abstract log sync object. Logger file name manager, and I had suggested we have an interface up here, right? file name manager. So let's bring this in, and I already had logger formatter, so I'm going to grab this interface, bring that in, and here file name manager, and it implements name new log file, right? I have my logger formatter with my normal logger formatter, and we had implemented the exception logger formatter. I'm not going to reference that here. And I'm going to get rid of this, get rid of these for now. And to help with that composing that's going on, and actually, where was it? The logger file name manager here is referenced here. I'm going to change this so that it's not referencing logger file name manager. It's referencing file name manager. And let's see, the other one we had, the logger formatter is being used down here. So I think I'm okay. I think I'm only referencing, yep, I'm referencing log sync. I'm receiving my logger formatter to do logger format the log message. So that's great. I'm only referencing, right, those abstract classes and interfaces, but I need to use those dependencies. I want them to be made available so that it's easier for me to specify these things, because, right, I'm going to remove these comments because they're no longer needed here. Right, and let's just add a note here. Now referencing the interface in as a type instead of the file name manager class, right? We're still coupled to it here because we're specifying it right there, right? And file name manager, I already took care of that. Referencing the log sync abstract class so that we can change our abstract interaction with log syncs later. Okay. So, and referencing the logger formatter so that we can inject the desired format. Desired formatter, right? So we're passing these dependencies. They're already defined. They're already interacting, and we're not, right? Our interactions to work with these objects, our logger, our formatter, are only using that interface, only using that abstract class, right? Similarly up here, only using that file name manager interface. And when I execute this code, it still works and outputs appropriately. But I'm directly coupled to those objects. I'm passing a new object here. I'm creating up here a new logger file name manager. And this feeds into the next, right? So this is solid, right? We're depending on those abstractions, not the concrete interactions as we go through later on in our class. So realistically, we don't want to create those objects, and this is where the concept of dependency injection comes in. And this phrase, new is glue. We've separated the references and how we use these objects, so we're only referencing interfaces and abstract classes. But we're newing these up. We're still glued to those types. If something happens and normal logger formatter starts to take a constructor argument here, well, when I update normal logger formatter and I introduce that argument here, now I need to go and update my logger manager to be able to interact with it. We don't want to do that. That new statement is glue. It glues these two classes together, these two files. If you made a change in the normal logger formatter, you have to change your logger manager. If I made a change to file logger and how it's created with that new statement here, I need to change logger manager. New is glue. So if we want to loosely couple these, if we want to really get to loosely coupling, we should pass those objects in. We should inject the implementations of logsync, of iLogger formatter, so that external consumer of our logger manager is what's controlling these. Okay? Hence the term inversion of control. We're injecting the concrete implementations of our dependencies. It's not being controlled by our logger manager class, but instead control has been inverted. It's being passed in from outside. So there's two different ways you can do this, and you can, well, there's several different ways you can do this. You can pass things in through the constructor of your class. These are dependencies that are required in order to use your class. So in this way, the only way to construct your class is if the dependency has been provided. That's important. You can't access, you can't interact with this without providing that formatter, that file sync that knows where it's going to go and save those files. You can also use property injection. Specify a property, and that property must be set with, here's the thing that you need in order to use this class. Now, folks like to sometimes use properties to allow optional dependencies to be set. This is a way, maybe you have a default implementation. I had that normal formatter. Perhaps you have that still you want to have lingering around, and you can have a property where you'll set anything that you want further detailed. You want to implement a further, more descriptive interaction of how you want things formatted. You can use property injection. Method injection is what we were using inside of our format message interaction, where we were passing in a class that had that business logic to implement the open-close principle. We were passing that in, so we were injecting the object that we need only in the method that needs it. This way that object isn't lingering around and floating for folks to potentially and inadvertently interact with it when they shouldn't be. Hold off on talking about about containers there, friends. Let's hold off. I see a lot of discussion about this. Let's get there. We'll get there. And about object lifetime, I'm going to pin that question. Hold that thought. I see a lot of folks that are really excited in chat about this topic. We're going to get there. I promise. So digging in, right? So I have this original logger, and in fact, let me get rid of this original logger. I don't need this source code here. Let's get rid of this one, and I'm going to copy down that implementation we just finished. Okay, and here it is. So with our log sync, our file name manager, here's our file logger, and you see, right, that file name manager, we need one of those in order to interact. We're defaulting it to a new logger file name manager. So we should really be passing that in from outside of our object so that this object doesn't necessarily know what a file name manager does, what the logger file name manager has that it's interacting with. So if we do that with the constructor here, because this requires a file name manager, it's kind of important, I will specify, and this is probably one of the most popular ways that folks do dependency injection is through constructor. It's very easy for you to then see everywhere that something's being injected. So I'll just call this file name manager, and right, I can get rid of that implementation, and I can say, let's see, file name manager equals file name manager. I'm stashing a copy of it in the private variable so I can go reference it later. I am using it right away here to name the new log file and create a new file. Like I said, this is a basic sample. It's intended to be overly simple. So these operations might occur in your log file manager somewhere else entirely. And for the purposes of this, we're just trying to make it real simple to connect the dots of where these things that reference interact with each other. So I put them next to each other. Now, when that file logger is being referenced, right, down here inside of my logger manager, well, I can't just new create one of those. And in fact, I don't want to just new create one of those here. I want to receive just a log sync and pass it along. So once again, I want to pass in. I need a log sync for my logger manager to know how and where to log its messages. So I'm going to provide that constructor argument, and I'm going to set logger equals whatever that sync is, and now I remove that new statement. Now my logger needs to be provided from outside, and this new logger manager doesn't know what to do with this. So I can now inject those dependencies by specifying that I'm going to pass in a new file logger. Right, so let's do that. And I can't just pass in a new file logger. I need to pass in a file name manager. Well, a file name manager is one of these. So I'll pass in one of those. And that looks a little unwieldy, right? If I execute the code, it works. It all behaves. And I've now got these abstractions that are being referenced inside of Logger Manager. Logger Manager doesn't know what file logger and what log file name manager are. It knows only how to sync and how to write and how to format messages, how to pass that along. So we now have ways that we can change that behavior by passing in objects, and I can certainly refactor this and turn these into right var objects out here. Right, if I have new, if I call this file sync equals, and I could do this, right, and further simplify. Right, so I'm passing that in. Well, right, I can also break this out. and call this file name manager, right? And var file name manager equals that. And that's nice. That looks a little bit easier for me to process as a human reading this. But now somewhere else in our code, we've got all of these new statements that make it a little bit tricky, a little bit, right? I need to know and wire these up appropriately. So I'm either going to have some sort of a catalog class that defines here's what these things are and how to reference them and how to build them. And right, how they relate to each other. Or, well, and gosh, I'm going to start to worry about scope. I could get into memory leak here because, right, when do these things need to be cleaned up? When do they need to be released? Maybe they need to stick around for the lifetime. Priyank actually asked this question a minute ago, and I parked it here. How do you control that object lifetime? My file manager, my file logger, I probably want to close and recreate when we have new files that we want to write, where my logger manager, I want to keep that logger manager around all the time so that I can always write log files and log messages to somewhere on disk or out on a web service so it can be consumed by my support staff, by my support team. That's important. So we start to get into questions about lifetime of these, because if we're creating new ones of these and they're sticking around for a long time, that's a memory leak. You're creating objects and you're not cleaning them up afterwards. So how do we do that? How do we handle that? And this is where the concept of an inversion of control or a dependency injection container comes in. And you'll see interactions with containers, particularly it comes by default with ASP.NET, ASP.NET Core with Blazor. You'll see these being used to define, here's an interface, and by default, whenever that interface is requested, we need to provide a concrete type. Not Docker containers, no. Docker containers, something different. Well played. But this is a container that contains your mappings from interface or abstract class to the concrete class that you would prefer to be passed in. And it will specify and provide that interaction appropriately. Now there's many different inversion of control containers out there. Dependency injection containers. You'll see both names used for this design pattern, for this utility object. There's a very simple one that comes by default with ASP.NET Core. It's also used as part of Blazor, because Blazor is part of ASP.NET Core. But there's literally dozens of them out there that folks have written, that folks have used, and it can be as simple as defining an object that specifies what this mapping is between objects. So if we were to just mock up a class that does that for us, watch this. Fritz is going to code this on the fly, right? Let's call this the Fritz container. Nothing bad ever came of writing code live on stream. You know what I mean? Autofact structure map, Ninject, Prism. Yeah. There's tons of them out there. Castle Windsor. There's a bunch. So if I specify a container, I'm probably going to have some mapping that lives out there. So I'm going to specify this as a private static read-only dictionary, and it's going to receive two types. And this is our mapping, and I'll create this as a new dictionary from this type to that type. Right? I'm not going to put anything complex in here to do these references, these interactions. You would have specified, and we'll see this in the ASP.NET source code. I'll show you that in a second. You would have specified some sort of a register interface, right? That's going to specify a type and another type, right? And one type implements the other. And actually, we would want to have this something like this, where it's an interface and it's a type. And what you would end up doing is saying mapping.add, something like register mapping. Something like that is the format that you'll typically see. So you would say mapping add, and it would be the type of the interface to the type of that type. And at some point you would have some sort of a method called resolve, requesting an object of some type. Right, and there's other ways that folks do this where they pass in different scopes, different instances of objects, and in this very simple implementation, we would return, right, some sort of a, and actually this was going to have, there's going to be a where in here, where t is new, because you want to be able to create a t. Right, and you would say something like this, and it's not just like that. It would inspect the constructor and figure out exactly how to create that type, right? And actually, we want to, it wouldn't just say new t here, it would be new mapping of whatever that type is. Like that, right? Which is kind of weird. It's going to get that type out, and we're going to go and create it. And I don't want to get down into the minutia of reflection, but at its simplest, this is what it's doing. Now, we could dig in and go into how this is implemented. There's all kinds of strategies for how this is implemented, but we can look further into ASP.NET Core and see exactly how these interactions occur inside of that very simple interface. I also need where ti, you're right. Right, it's going to be something like that, where t implements I. I forget exactly if I have that comma correct there. Might be. Okay, so if I were to go and show you now a basic ASP.NET Core application, so that we can see exactly how this is implemented over there. Let me see, let's create a new folder here. I'm going to go into, let's call this ASP.NET sample. And I'm going to create a new ASP.NET Core application here, just so we can see what that register method looks like. And I'm going to let's create a web app. So .NET new web app. And we'll get into command line interface as we get into the actual implementation of an application format here. And that'll probably be with .NET 5 in November. So inside of ASP.NET Core, we have a startup class. And we implement our dependency injection here inside of this configure services method. And this is saying services add Razor pages. This says add the Razor pages service, so that whenever something requests to interact with Razor pages, the things that format our application, it's going to resolve and make that available for you. We can also do things like, say, rats, my tabs aren't going to line up. Services add transient, right? And I would specify some interface, right? File name manager, normal file name manager. And what this does is it specifies, just like I showed you over here, right? It's registering a mapping. It's creating a mapping from an interface to a type, so that whenever a file name manager, an iFile name manager is requested, the normal file name manager will be constructed and provided for you. So these things can then be requested by creating classes that have constructors that request an iFile name manager interface. Now, scope and making sure that we only create those objects when we need them, we reclaim them when we don't need them. That scope of how long that object lives is defined by this add transient statement. There's 3 different scopes that you'll see used inside of the ASP.NET Core service locator, this dependency object, this dependency injection container. Not only is there add transient, but there's also a scope called scoped. And there's finally one called singleton. Transient means every time that I request an iFile name manager, this object is created for me. A singleton says that when this object is requested, iFile name manager, one and only one normal file name manager is created for this instance of the application and is managed for the entire lifetime of the ASP.NET Core application. It will never be destroyed, and it will never be recreated by the service locator, by the container. That's important, because if you put things into there that it should be destroying and recreating, it's not destroying and recreating those, it's hanging on to them and will linger, and you may inadvertently be creating a memory leak. Now, I skipped the one in the middle. A scope called scoped. That's weird, Fritz. What are you doing to me here? In this case, when we think about processing and producing a web page, right? And that's what ASP.NET is. It produces web pages. In ASP.NET Core, when we produce a web page, there are times where we want to create an object only for the duration of when we're rendering that web page. Great example of this is interaction with a database. If you're interacting with a database and it's specific and we want to make sure that it's secured and only available to the interactions that that user, that visitor to your website is doing from the point that we began processing the web page or the API that they're interacting with to the end of that, and we finally finish delivering all the content to that visitor. That is the scope of a request. So add scoped says create one file name manager, in this case, only one iFile name manager, a normal file name manager, and if any other classes, any other objects during this one web page request, this one API request, ask to interact with a file name manager, give it the same one. This means that when I interact with the service, Fritz gets his own version of file name manager. When Jason, I see Jason there in chat, when Jason makes a request to the service, Jason is handed Jason's instance of the file name manager. Different, it's a different instance than the one that Jeff is working with, that Fritz is working with over here, okay? So there aren't any chances for those two objects to collide in memory, for me to inadvertently access and interact with anything that Jason is interacting with, because they're kept separate and isolated. You typically see this used for database interaction. You see this for authentication interactions, so that your authentication, your interactions with your roles and your security claims, those things that are security significant, to grant you access to an application, or to grant you access to the appropriate data you're interacting with in the data store, are maintained separately from other users. That's where you want to see that scoped interaction happen. Marcus, that's another great example there that we should highlight. You don't want to share a shopping basket with another user on a website. Absolutely, right? Mrs. CSharpFritz is out there doing holiday shopping, and I go and log on from my machine, and we're on the same network. It shouldn't inadvertently show me, Mrs. CSharpFritz's shopping basket, because now I'm going to see what I'm getting for holiday. Hey, that's while that might be fun for me to see, for you as an application operator, you've just violated your customer's trust. So those are examples of the 3 different scopes that come with the default dependency injection container. The service locator is the pattern that it's implementing that you see inside of ASP.NET Core. And yes, I'm doing this with no IntelliSense, and I'm purposely doing it in Notepad because I don't want to bring in and get into things with Visual Studio or Visual Studio Code yet. Okay. I think we do need to get into Entity Framework in the next episode. But we've gone through a lot here. We've really discussed a lot about how you can interact with, how you can write code that adheres to these principles. And these are principles. They're not laws. They're really more of a recommendation. They're kind of a guideline. And you cannot request a bargain parlay like a Pirate of the Caribbean here. But they're principles that if you follow them, they'll help make your code better, more maintainable, and perhaps you'll even find some places where you can optimize for performance because you've started to isolate the responsibilities of your application. You've started to place things discretely into different locations so that it's easier to maintain. Source control will be easier to maintain because you've broken out a very complex object so that it's now residing and is being composed of all the various child responsibilities that could be interacting and managing that object. It's important that you understand that this isn't required, but you're going to be able to do much better things when you do implement and you pursue design patterns, design principles, like the solid principles. Dependency injection isn't required, and in fact, some of our friends that work on mobile apps will tell you dependency injection and implementing many different interfaces for a mobile application ends up creating more code and more code management than what you really need, where on a mobile device, we want as small a code base as possible. And in that case, creating one object that knows how to do all the things that's appropriate for that mobile device may in fact be more appropriate for that solution versus in a desktop application, a web application, an IoT application. You may want to have these, or a cloud service, you may want to have this broken out into more discrete objects that you can deploy appropriately. Certainly if you're deploying some of these objects to an IoT device, you want those to be as small as possible, and implementing those very discrete interfaces so you only deploy those things will be beneficial. Devin, you're spot on. In implementing these principles, you must at some point visit one of the next tenets we need to get into: testing. And the more that you test your code, the more assurances you'll have that each of these individual components that we've now broken things out into are going to work appropriately. You're right, Jason. Inside of ASP.NET Core, let me highlight this. inside of ASP.NET Core, there are some helper methods around that services object to help register interactions with database, to help register interactions with web servers using what's called the HTTP client. There are shortcut methods that'll register and configure that for you, and we can get into that more when we start down the ASP.NET Core application series that I think we'll end up starting probably late November is what we'll be looking at, because we're going to end up with a week off for .NET Conf. We'll have a week in there where we'll do some C#9 discussion. And I think we want to drop in a unit testing discussion at the beginning of the month as well. So, actually, no, next week is the beginning of the month. So we'll do database next week. We'll probably do unit testing after that, C#9, and we'll get into ASP.NET Core. Testing factory, nah. Gosh, no. What about, well, what about using statements versus dependency injection? I would lean towards dependency injection and pass that control outside of your object so that it's being handled appropriately. You can create your objects and use a using statement to populate. Populate those dependencies. That works as well. You don't have to use the dependency injection container, that service locator object. You don't have to use that. You can use using statements to compose that appropriately and take direct control over how that interaction happens. But you don't need to do that. Taking a look here. I think we're about done then. We're done a little bit early today. That's all right. So let me head over. Let's head back over to our main display. This one. I want to be over here. And we've covered a lot. These principles are not something that you're going to learn overnight. They're not something that you're going to be an expert at immediately. But there's something that you can practice, you can explore, test out a little bit. And that's why it was important to me to use Jupyter Notebooks for this. Tinker with some of that source code, add some new features in there, see how it ripples through the rest of the architecture for that logger object that we created. Break things. You saw what happened when I put in some errors. Hey, you get a little error message that happens below. No big deal. Go ahead and do that and figure out what patterns, which of these principles make sense to you. Things that maybe you haven't tried before. Take a look and see if it starts to make sense. Dependency injection isn't required to work with ASP.NET Core. It's something that will help make your interactions easier. But take a look at what's involved there. Take a look at how I wrote some of that code where we're injecting the objects in by hand and what that means for your application. I think that's all the time we have for today. I'm gonna wrap it up right there. Make sure, yeah, there it is. And I think we're gonna call it the end of a stream. Thank you so much, friends. I really appreciate you tuning in. If you're watching the YouTube recording, check out the entire playlist of all things in the C# with CSharpFritz catalog. You're going to see a little button that appears right about here that'll take you back to our previous episode 8, and there'll be another button up here somewhere that'll take you to the entire playlist so you can click through and watch all the videos. For those of you watching on Twitch, in a few hours, this video will be available over there. And I hope you come back around next week, next Monday, 9 a.m. Eastern, 6 a.m. Pacific. Right? Tune in before you go out for your morning jog, or even listen to me during your morning jog there on the West Coast, or 1300 UTC. Finish lunch and tune in and join us over here, and we're going to talk next week about database with entity framework and how you can interact with a database using the simple entity framework object relational mapper tools. And I'm going to have a blog post in just a few days that shows the schedule of all the sessions coming up and with links to the rest of the playlist for you. Thank you so much, friends. I really appreciate you tuning in, and I'll see you next time.